A small signal, but a big reaction. After confirmation in January that the Rosetta spacecraft had woken up in deep space, ready for the most important phase of its comet-chasing mission.
Getting it back is incredible. It's really, now we have one of the most fantastic adventures in front of us, one of the most challenging space missions ever.
Rosetta's challenge is to find out more about the origin of our solar system and obtain clues of how life and water came to Earth. It will do this by exploring the comet at close quarters, flying alongside, orbiting and landing on it.
Later in springtime we will switch on the scientific instruments, verify them, and this will bring us to the detection of the comet. We want the cameras on board the spacecraft to see the comet so that then we can maneuver the trajectory of the spacecraft to the right direction.
There's also an exact copy of the spacecraft at ESA's Space Operations Center for testing. And when Rosetta woke up after being in deep space hibernation since 2011, one of the first things it did was to warm up its star trackers.
This is one of the star trackers of Rosetta. We've got two on board. They're basically big cameras which are looking at the stars, and from the pattern of the stars, using maps which are stored on board, they can tell the onboard computer where the spacecraft is looking in the universe.
Over the next few months, the excitement will build once more as the spacecraft gradually approaches Comet 67P Churyumov-Gerasimenko, making continual observations of its icy nucleus.
We shall be around the comet this summer, and we shall land on the comet in November. And after that, until at least mid-2015, we shall be on the comet and around the comet to see how the comet is living for more than 1 year.
Rosetta's robotic Philae lander will be the first controlled landing onto a comet. Its 10 onboard instruments will then examine the comet's surface alongside the additional 11 instruments on the orbiting spacecraft. And by studying the comet from orbit and on the ground, mapping its surface and examining changes in its activity, Rosetta will produce a scientific goldmine.
It's going to provide us with an unprecedented characterisation of a comet. This is groundbreaking science we're going to do, and that will lead us to a journey back in time to the origins of our solar system. And from that will provide us with a better understanding of how the solar system was formed and its subsequent evolution to how we know it today.
As comets are frozen cosmic time capsules, Rosetta will be able to sample material from the gas and dust cloud that gave birth to our Sun, the planets in our solar system, and life on Earth.
The comets were there right at the beginning in the solar system. They were flung out into deep freeze, storing this information, this primordial mix of material, and that gives us a clue to, in fact, ultimately where we come from as well.
The most difficult part of the mission, the final rendezvous, lies ahead. Between now and May, Rosetta will start slowing down as it approaches the comet. The team will also try and avoid any comet dust, as the first camera images will help improve calculations of the comet's position, orbit, size, shape and rotation. Rosetta will then be another step closer to making history.